Hello students, you are watching Chemistry Wins YouTube channel. Welcome back. So this session deals with a discussion on solid lubricants. Okay, right. The lubricating oils and greases cannot be used under the following conditions. So there are certain conditions under which you cannot use grease or liquid lubricant. Okay. So the condition number one is where the operating temperatures and pressures are too high, the liquid lubricants cannot be used because these are easily combustible. So the liquid lubricants will become burnt if the operating conditions are high. Okay. Then the second cause is where a liquid or semi-solid lubricant cannot be maintained in a position. So the slippery, in sometimes the situations will be where the lubricant cannot remain in its position. So that doesn't offer any use. Okay. Then the third condition is where the contamination of lubricating oil by the entry of dust particles is undesirable, such as in aerospace devices. So in the aircrafts, there will be contamination of lubricant oils because of entry of dust. Okay, so such a condition is not desirable. So under these three conditions, you cannot use grease or lubricating oil for the proper lubrication. So under these conditions, solid lubricants are highly useful. Okay, hence under the above conditions, the frictional resistance will be minimized by using solid lubricants. Okay, then most widely used solid lubricants are graphite, number one, and number two is molybdenum disulfide. So solid lubricants offers they are going to work under different conditions. Okay, right. So let us discuss about graphite. So you know that graphite is an allotrope form of carbon. It is the most widely used solid lubricant. So graphite is the most widely used solid lubricants, right students? Then you can see the structure here. So graphite contains layers of hexagon carbons. So each carbon is sp2 hybridized. Okay. Then graphite contains layered structure and the adjacent layers are connected together by van der Waals forces of attraction, and each layer is separated from another layer by a distance of about 3.4 angstrom units. Okay, so that is the structural feature of a graphite. Okay, right. So this is multiple layered structure of graphite. So graphite consists of a network of hexagonal carbon rings separated from the adjacent layer by a distance of 3.4 angstrom units. So we have already seen this point. Then the adjacent layers are held together by weak van der Waals forces. Hence the parallel layers slide over one another. So in the graphite, the layers of hexagon carbons are held together by weak van der Waals forces. So the van der Waals forces here represented in the form of dots. Okay, the dotted lines. So these dotted lines represent van der Waals forces. Okay, so because the van der Waals forces are weak, the layers will slide over each other, so offering a smooth movement between the moving metal surfaces. Okay, right. Graphite is soapy to touch, non-flammable, and not oxidized in air below 375 degrees centigrade. So graphite, when you touch graphite, it appears like a soap and it does not burns, and it is stable to oxidation below the temperature of 375 degrees centigrade. Okay, then graphite is used either in powdered form or as a suspension. You can use graphite in the form of powder, or you may mix it to give a suspension. Okay, suspension of graphite is prepared in oil or water using tannin as emulsifier. If you want to prepare a suspension of graphite, you need an emulsifying agent like tannins. Okay, then students, graphite suspension in oil, in petroleum oil, is known as oil dag, and it is used in internal combustion engines. Okay, then graphite suspension in water is called aqua dag, and it is used in food industry. So the food industry doesn't require usage of graphite with petroleum oils. Okay, right. So you may mix graphite with water, and that lubricant is called as aqua dag. It is highly useful in the food industry. Whereas if you mix graphite with petroleum oil, that will give oil dag. So this oil dag is highly useful in the automobiles. That is, they are used in the internal combustion engines, the motor engines of automobiles. Okay students, so that is the widest application. Then let us see the general applications of graphite. So graphite is used in air compressors, in general machine shop works. Okay, then it is used in food industry as a lubricant. Then the railway track joint. So the railway track joints are lubricated by using graphite. Then chains and open gears, internal combustion engines, that is in automobiles. The automobile engines are also provided with the lubrication offered by the graphite. So that's about graphite, students. Now let us go into the second solid lubricant that is most widely used is molybdenum disulfide after graphite. Okay, you can see this is the structure of molybdenum disulfide, MoS2. Okay, so at the center it has a sandwich like structure. That means at the center there is molybdenum atom layer, and the molybdenum atom layer will be surrounded by top and bottom by the two layers of sulfur. So sulfur atom layer at the top and sulfur atom layer at the bottom. Okay, right. Molybdenum disulfide has a sandwich like structure in which a layer of molybdenum atoms lies between the two layers of sulfur atoms. So the molybdenum layers, the atom of molybdenum layer will be present at the center, and these two are this layer is will be present between the two layers of sulfur atoms. Okay, at the top and bottom, at the top and bottom. So that appears like a sandwich. So molybdenum disulfide is said to have the structure of a sandwich, right? Then the another feature of molybdenum disulfide is it has low coefficient of friction and is thermally stable in air up to 400 degrees centigrade. So molybdenum disulfide is stable up to the operating temperature of 400 degrees centigrade. It remains very stable. If temperature increases beyond 400, it will change. Okay, then molybdenum disulfide is used as a powder or it may be mixed with solvent just like graphite. Then what are the applications? Molybdenum disulfide is used in airframe lubrication and wire drying dyes. So those are the applications of molybdenum disulfide. Then apart from graphite and molybdenum disulfide, you may use talc, mica or soapstone as a solid lubricant. Not only graphite, molybdenum disulfide. So there are some other solid lubricants like talc, mica, soapstone that are also used as a solid lubricant in order to reduce the friction. So that is about this video, students. Thank you for watching.